Hey guys, so this year CSAT was on the tougher side and the most of the questions from the quantitative part required much higher level of thinking to solve. So in that situation, when you are writing the exam, you will be in a very stress situation. So in that stress situation, to do all this thinking and then to solve these questions was actually very challenging this year. Okay, so all those who are preparing for the prelims in 2024, they should not take CSAT lightly. They should take it seriously and they should practice tougher questions along with PYQ, and you should make it a habit to solve CSAT questions every day. Like you should spend around 15 to 30 minutes every day till the prelims. Okay, and I will be posting the solution video for this year's CSAT paper in parts. So this is the first part of that video, and I'll be trying to explain to you the solutions of different questions in a very simpler way. And if you have any doubts, you can post it as comments as well. So if you like this video, please do subscribe, share and support. And if you want to join my Telegram channel for support and daily questions and all, you can join it using the link that I'll be providing in the description box. So now let us start with the video. So let's take this question first. A box contains 14 black balls, 20 blue balls, 26 green balls, 28 yellow balls, 38 red balls and 54 white balls. Now consider the following statements. So in this year's CSAT paper, the understanding of the question is actually very important. So you, in that stressed situation, I already told you, in that stressed situation while we are writing the exam, it's actually very difficult for you to keep your mind calm and to understand the question. But that understanding of the question was actually very important this year. That thinking part was very important this year. So let's take the first statement here. The smallest number n such that any n balls drawn from the box randomly must contain one full group of at least one color. Okay, that is 175. So here we are taking one ball at a time randomly, and the statement says that it must contain one full group of at least one color. So one full group of black means there are 14 black balls. One full group of blue means there are 20 blue balls. So at what point we are taking one ball at a time, then at what point we can say that the balls that we have taken out will contain one full group of at least one color. Now let's assume that I have taken 13 black balls first. Okay, actually there are 14, but I am only taking 13. So the full group is not taken out, only 13 is taken out. Now let's say that in 20 blue balls I taken 19 blue balls. In 26 green balls I taken 25 green balls. In 28 yellow balls, let's say I have taken 27 yellow balls. And in 38 red balls I have taken 37 red balls. And in 54 white balls, let's say I have taken 53 white balls. So after I have taken all these things, still I haven't got one full group, right, of at least one color, right, because I have taken only one less than the full group. Now if you add all these things, you will get 174. That means at the point that you have reached 174, you cannot say that you will be taken one full group, right? Now if I take one more ball, it can be black ball, it can be blue ball, it can be green ball, it can be yellow ball, it can be red ball, or it can be white ball. Then if I take one more ball, if I take a yellow ball, then I can say that the yellow completed one full group. If I have taken the red ball as 175th ball, then I can say that I have completed the red full group, right? So in this way, we can say that after 175 balls are taken, we can surely say that it will contain at least one full group of one color, right? So this is actually correct. You got it. Now let's take the statement 2. Statement 2 says that the smallest number m such that any m balls drawn from the box randomly must contain at least one ball of each color. So at least one ball of each color should be there. So here what I can do is that let's assume that I have taken all the white balls first. So I have taken 54 white balls first. Then let's say that I have taken all the red balls. So 38 red balls I have taken. Then I have taken 28 yellow balls. Then I have taken 26 green balls. Then let's say I have taken 20 blue balls. Okay, So I haven't taken any black balls. So statement 2 says that we have to take at least one ball of each color. So now I have taken all the colors except black. So I haven't got at least one ball of each color. If you add all these things, you will get 166. This means that if I take one more ball, that ball will be the black ball. So if I take one more ball, that is the 167th ball, then I will be having at least one color of all the ball, right? At least one ball will be there of each color, right? So this is also correct. So option C was the right answer. Both 1 and 2 will come. Okay. So now let us look into the second question. So this was actually a simpler question. Here, if 0 is written as CHUR, so 0 is written as CHUR. So we need to find out the relationship between 0 and CHUR. Here, if I am writing A, B, C, D till Z, and then I am repeating A, B, C, D like that. If I am going like that, after Z, A will come, then B will come, then C will come. Then after E, F is coming, then G is coming, then H is coming. After R, S is coming, then T is coming, then U is coming. Then after O, P is coming, then Q is coming, then R is coming. So in between Z and C, there are 2 letters. In between E and H, again, there are 2 letters. So that is the relation. So we got the relationship. Now we need to see how player is written. Okay. So here, if you look into the options, you can see that all the options start with S, right? All the options are starting with S. So you don't need to look the P1. You don't need to look the coding of P. Now second option, if you look into all the options, second letter is also O. All the second letters are O. So you don't need to look into this. So just take the options. Okay. So here, the third option, there is C and D. So I am just going to check what will come for A. What is the code for A? So A, B, C, then D will come, right? Because in between A and D, there are 2 letters. So D is the letter. So I can eliminate option A. Now, again, next one is everything is B. So I don't need to look into Y. Now E, after that F is coming, then G is coming, then H is coming, right? So I can eliminate B also. Now for R, then it will come S, then it will come T, then U will come. So this also I can eliminate. So option D is the right answer. So let's solve this question. Consider the following statements. So 5 statements are given. A is older than B, C and D are of the same age, E is the youngest, F is younger than D, F is older than A. So the question is, how many statements are required to determine the oldest person? So the question is not like who is the oldest person or something. We need to check whether how many statements given above are required to answer the question. So if you analyze these statements, you can see that there are 6 persons here. A is there, B is there, C is there, D is there, E is there, and F is there. So 6 persons are there. So among these 6 persons, we need to see who is the oldest, right? So here I will tell you a trick here. Now, if I let's see how many statements are required here. Okay, required to answer this question. Now, if I consider this statement 1. Statement 1 talks about A and B. Okay, the relationship between A and B, and none of the other statements talks about A and B. Only this statement talks about A and B. So this must be required to answer the question, because we should know the relationship between all of this. Then only we can find out who is the oldest, right? So only statement 1 talks about A and B. So anyways, statement 1 will be required to answer the question. Now similarly, if you see, statement 2 talks about C and D, and C is only, you can see C only here. In none of the other statements C is there. So we can say that this is also required. Now in the third statement, it talks about E, and none of the other statements talks about E, right? So this will be required. Anyway, this will be required. Now if you look into fourth option, it talks about F, and F, you can see that F is being talked in this statement 4, and also statement 5 also talks about F. So one of the statement from 4 or 5 will surely be required. So let's say that this is required. So now we know that minimum 4 statements are required to answer the question. So it could be 4 or 5, right? So anyway, we can eliminate these 2 options. So either 4 statement will be required to answer the question, or 5 statements will be required to answer the question. Now you just try to solve this one. So first statement says that A is older than B. Second statement says that C and D are of the same age, so C is equal to D. Third statement says that E is the youngest, so E will come last. Now fourth statement says that F is younger than D. F is younger than D. So we have written like this. Now we should get a relationship between this and this. Okay, then only we can say who is the oldest, because sometimes A can be the oldest, sometimes C or D can be the oldest. We don't know. Now if you look into the fifth statement, it says that F is older than A. So F is older than A means we can draw like this. And E is the youngest, so we can draw like this. So now we can say that C and D are the oldest person. Okay. So by analyzing, by using only all the statement, we were able to come to the answer. So all 5 statements are required. So D is the correct answer. Okay. So now let's take the next question. Consider the following, including the question and the statement. There are 5 members A, B, C, D and E in a family. So the question is, what is the relationship of E to B? How E and B are related? Now there are 4 statements given. Now the question is, how many statements are required? Actually, the option A says that 1, 2 and 3 are required to answer the question. So 1, 3 and 4. So that is the question. So here I will tell you again one trick I will tell you. So you need the relationship between E and B, right? Okay, you need the relationship between E and B. Now if you look into the statement 1, it talks about A and B, some relationship between A and B. And statement 3 talks about E and D. Okay, E is here. In statement 3, E is given, and in statement 1, B is given. So anyway, statement 1 and 3 will be required to find out the relationship between E and B. So we need to connect E to B. So here B is there, here E is there. Now here in statement 3, E is connected to D. Okay, so now we need to connect D to B, right? So using statement 2, we can connect D to C. And using statement 4, we can connect A to C. And using statement 1, we can connect A to B. So from just analyzing the statement, we can say that all statements will be required. You got it? So actually it was C. All 4 statements are required to answer the question. How I got it? Just by logic I have got it. I haven't done anything, right? We need to check what is the relationship of E to B. So here first from statement 3, I can connect E to D. Then from statement 2, I can connect D to C. Then from statement 4, I can connect C to A. Then from statement 1, I can connect A to B. So in this way, I can connect. So E and B are connected by using all the 4 statements. So all 4 statements will be required. So for checking, just try to solve this one. So it says that A and B are married couple. So A and B are couples. D is the father of C, but we don't know that. Now here statement 4 says A and C are sisters. So A and C are sisters. So C is female and A is female. So this will be male. Now here it says that D is the father of C. So D is the father of C. So D is male. Now E is D's son. Statement 3 says that E is D's son. So E will be D's son. So this is male. So now we can connect E to B. So all the statements are required. Okay. So let's see the next question. Choose the group which is different from others. So here if you look into the options, I have already told in many of my videos, in some of my videos, that you need to be well aware about the common things in maths, like the prime numbers, like composite numbers, natural numbers, whole numbers, etc. Okay, you need to be very thorough. And in this year question also, in previous year question and in 2021, 22, 23, etc., many of the questions had the concepts. All these concepts were there, like natural number, whole number, integer, okay, prime number, composite number. So you need to be well aware of all these concepts, also odd number, even number and all. So you need to be well aware about that. And I think I have already told you to be well aware about all these topics as well. So and I have already told you that you have to study, you have to by heart the prime numbers at least till 50 and all. Okay. So now if you can identify that these given numbers are prime numbers, then half your job is done. So if you have by hearted at least till 50 the prime numbers, you can after seeing the options, you can say that these are prime numbers. Most of these are prime numbers, right? So our duty, our thing, what we have to do here is that we need to find out the number which is not a prime number. So if you check all these numbers, 91 is actually not a prime number. Okay, 91, if you divide 91 by 7, you will get 13. Okay, 13 into 7 is actually 91. So 91 is not a prime number. So if you can identify that 91 is not a prime number, it's actually very difficult. Okay, only if you know the prime number, at least some of this prime number, then only you can come to this conclusion. But at least if you can identify that 91 is not a prime number, then you can say that option D is the right answer, because all other numbers are prime numbers here. Okay. So now let us look into the next question. So here 7 plus 9 plus 10 is equal to 8. 9 plus 11 plus 30 is equal to 5. So some things are given and they have asked the value of 23 plus 4 plus 15. So here if you add 7 plus 9 plus 10, you will get 26. If you add 9 plus 11 plus 30, you will get, this is 20 plus 30 is 50. You will get 50. If you add 11 plus 17 plus 21, you will get 28 plus 21 is 49. So this is what we get if we add this number. But it says that this is equal to 8. This is equal to 5. This is equal to 13. So if we can somehow relate this to this and this to this and this to this, then we can find out the answer here. And you know that 2 plus 6 is 8. 5 plus 0 is 5. And 4 plus 9 is 13. So in this way we can find out the answer. So 23 plus 4 plus 15 is actually 23 plus 4 is 27. 27 plus 15 is 42. So if you add 4 plus 2, you will get 6. So the answer is option A, 6. Okay. So let's solve the next question. So let x be a positive integer such that 7x plus 96 is divisible by x. Then how many values of x are possible? So it is given that 7x plus 96 is divisible by x. Okay, I can write it as 7x by x plus 96 by x. Okay. Now if you see this one, 7x will be anyway, it will be divisible by x, because I can cancel x and x like this. So 7x is divisible by x, whatever the value of x, right? So we just need to check this one. So we need to find out the values of x such that 96 is divisible by x. So what we need to do? We need to find out the factors of 96. So 96, I can write it as 1 into 96. I can write it as 2 into 48. I can write it as 3 into 32, right? I can write it as 4 into 24. I can also write it as 6 into 96. Sorry, 6 into 16. I can also write it as 8 into 12. So these are the different ways I can write 96, right? So now here 1 will be 96 will be divisible by 1, 96 will be divisible by 96, 96 is divisible by 2, 96 is divisible by 48. So in this way, all these numbers, all these factors, so 96 will be divisible by all these factors. So how many numbers are possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, 12. So 12 numbers are possible. 12 values of x are possible. Okay, so option C is the right answer. So let's look into the next question here. If P, Q, R and S are distinct single positive numbers. So distinct, that means they are different. Then single digit, so they are single digit positive numbers. Then what is the greatest value of P plus Q into R plus S? So we need to find out what is P plus Q into R plus S. So here we know that if the value of P, Q, R and S are greater, then the value of P plus Q into R plus will also be greater, right? So we need to look into those digits. So we know that they are single digits, right? So we need to take the largest digits. So we can take 9, 8, 7 and 6 because they are distinct. They cannot be the same number, right? So we can take 9, 8, 7 and 6. So just try different combinations here. So let's say P is 9 and Q is 8. So that will get 9 plus 8 into 7 plus 6. Or it can be like 9 plus 7 into 8 plus 6, right? Or it can be like 8 plus 7 into 9 plus 6, right? So this is 17 into 13, right? This is 16 into 14, and this is 15 into 50. So just check all these values. So if you do 17 into 13, you will get 221. If you do 15 into 15, you will get 225. And if you do 16 into 14, you will get 224. So out of this, 225 is the highest value. So the answer is option B, 225. Okay. So let's do the next question here. A number n is formed by writing 9 for 99 times. So I am writing 9, 9, 9, 9 like this till 99 times. I am writing 9. Okay. Now, what is the remainder if n is divided by 13? So if this number is divided by 13, what is the remainder? Okay. So here you need to know the divisibility rule for 13. Okay, or rule of 13. I have already done a video on the rule of 7 and 13. So rule of 13 is 1, 4, 3, minus 1, minus 4, minus 3. We are going to apply that here. Okay. So there are many 9s. So 9s, it's going like this. Okay, 99 times. So I am applying the rule for 13 here. That is 1, 4, 3, minus 1, minus 4, minus 3. Then again it's going to repeat 1, 4, 3, etc. etc. It's going like this. Now if you see here, how we need to do here, 9 into 1 plus 9 into 4 plus 9 into 3 minus 9 into 1 minus 9 into 4 minus 9 into 3. This is going like that, right? So this and this will get cancelled, right? Because it's plus 9. This is minus 9. So it will get cancelled. This is plus 36 and this is minus 36. So this will get cancelled. So 9 into 3 is 27. 9 into minus 3 is minus 27. Again that will get cancelled. So for first 6 numbers, first 6 digits are getting cancelled in the rule of 13. So next 6 digits will also get cancelled in the rule of 13. In this way, the first 96 digits is going to get cancelled because 96 is it's a multiple of 6. So it will all get cancelled. So just we need to there are 99 nines, right? So all the first 96 nines will get cancelled in the rule of 13. So only remaining is 9, 9 and 9. So we just need to check when 999 is divided by 13, what is the remainder? That will be the same as 9 coming 99 times. Okay. So here what will come? Just do this. 7 into 13 is 91. Then this is 89. 6 into 13 is 78. So you will get remainder as 11. So option A is the right answer. Okay. So here next, let's look into next question. Each digit of a 9-digit number is 1. That means there are like 9 ones are there. Now it is multiplied by itself. So I am multiplying again this number with the same number. So then we will get an answer. Then what is the sum of the digits of the resulting number? So if I multiply like this, what will come? 1 into 1 is 1. 1 into 1 again 1 will come. So in this way you will get 1, 2, 3, 4, 5, 6, 7, 8, 9 ones will come here. Then the next stage, if you are multiplying this one with 1, you have to write here, right? So it will come like this. And next one will come like this. So this is going in this way. So if I am adding all these things, first one will come here. Second 1 plus 1, 2 will come here. Then 3 will come here. Then the next stage will come, 4 will come here. 5 will come, 6, 7, 8, 9 will come. Then again it will come 8, 7, 6, 5, 4, 3, 2, 1. In this way it will come. Now if you add 1 plus 2 plus 3 plus 4 plus till 8, how many will come? That is 3, 6, 10, 15, 21, 28 and 36. So here also this will come 36. 36 plus 36 is 72. 72 plus the middle 9, you will get as 81. So the answer is 81. So just remember this thing. If I multiply 11 into 11, you will get 121. There are 2 ones. So 2 is coming in the middle. If I am multiplying 111 into 111, what will come? 111, 111, 111. 1, 2, 3, 2, 1. Because 3 ones are there. So 3 is coming in the middle. Then 2, 1 will come here. 2, 1 will come here. Similarly, if there are 9 ones, then 9 will come in the middle and then it will go like this. 8, 7, 6, 5, 4 like that. Here also 8, 7, 6, 5. This like that it's going. So using that concept, we can solve this question. Okay. So let's look into the next question. What is the sum of all digits that appear in the integers 10 to 100? So what is the sum of all digits? Now here you can actually use a trick. I am finding out the sum of digits from 1 to 99, not 10 to 100. Because 1 to 99 we have already studied. In the lecture of number system, I have already told you that from 1 to 99, the digit 1 appears 20 times. Digit 2 appears 20 times. Digit 3 appears 20 times. All these digits will appear 20 times. So it's actually easy for you to calculate the sum. So I am calculating 1 to 99 first, and then we will subtract whatever is required. Okay. So from 1 to 99, you know that the digit 1 will come 20 times. Okay. Digit 2 is coming again 20 times. This actually you had to by heart. If you want to know how this one is coming 20 times, you can actually try this. Like 1 is there, 11 is there, 21 is there, 31 is there. In this, all these things ones are coming. Just calculate it, you will get 20. Or you can go and watch the lecture on number system. Okay. So here in this way, 3 will also come 20 times from 1 to 99. All the numbers will come from, all the digits will come 20 times. So we need to add all these digits now, right? So how much will come? 1 is coming 20 times, that is 1 into 20. 2 is coming 20 times, that is 2 into 20. Sum will be 2 into 20. 3 is coming 20 times, sum is 3 into 20. In this way, finally 9 is also coming 20 times, that is 9 into 20. So if I add all these things, you will get, we can take 20 common. So 20 into 1 plus 2 plus etc. till 9. So 1 plus 2 plus etc. till 9 is n into n plus 1 by, you can use that formula. First n natural numbers, it is n into n plus 1 by 2. So here n is 9. So 9 into 9 plus 1 is 10, 10 by 2. So that is 45. So this, the sum will be 20 into 45, you will get 900. But we have calculated from 1 to 99. The question was from 10 to 100. So if I am calculating from 1 to 100, so 1 to 99, it is 900. 1 to 100 will be, you need to add 1. In 100, you have 1, right? So it will come 901. But I need to find from 10 to 100, not 1 to 100. So I have to subtract 1 to 9 from it. So 1 to 9, we have already calculated that 1 plus 2 plus 3 plus 4 plus 9 is 45. So just minus 45 from 901, you will get 856. So the answer is 856, option B. Okay. So now let us look into the next question. ABCD is a square. 1 point on each of AB and C. So I am first drawing a square ABCD. So this is ABCD. So 1 point on each of AB and CD. So I am drawing a point like this, and here also 1 point, and 2 distinct points on BC and DA. So BC I am taking 2 points, and AD also I am taking 2 points. Now how many distinct triangles can be drawn using any 3 points as vertices out of these 6 points? So total 6 points are here. We need to draw triangles. So how many triangles are possible? So here, even if the question doesn't speaks about any square or rectangle, whatever it is, if I have many points in a plane like this, okay, I have many points. Like for example, here 1, 2, 3, 4, 5, 6 points are there. I need to draw triangle. So for triangle, I can take any of the 3 points, because for drawing a triangle, I need 3 points, right? 3 vertices will be there. I can draw a triangle like this. If I take other 3 points, if I take these 3 points, I can draw a triangle like this. So if you are given n number of points in a plane, and you are asked to find out how many triangles you need to draw, then you just need to select 3 points out of the total given points. So here total 6 points are there, and you need to select 3 points out of these 6 points, right? That's it. So the answer will be 6C3, because you need to select 3 from 6. So the answer is 6 factorial divided by 3 factorial into 6 minus 3 factorial. So the answer will be, so you can cancel 3 factorial here, you will get 4 into 5 into 6 divided by 6 minus 3 is 3, 3 factorial is 1 into 2 into 3. So this is 6, this is 6, answer is 20. So let's look into the next question. 3 of the 5 positive integers p, q, r, s, t are even and 2 of them are odd, not necessarily in order. Actually, this is very important, this not necessarily in order. Okay, so consider the following. So 2 statements are given, we need to check which of the statements given are correct. So here you should understand the addition of odd numbers and even numbers very well. And I have already told you in my video and in my practice paper that is actually very important. Okay, so here you should understand that if you add two even numbers, even plus even will always be even. Even plus odd will give you an odd number, and odd plus odd will always be even. So this you need to understand very well. So here let us assume that, so we have p, then actually this is also same for subtraction as well. So I have given addition here. For subtraction also it's the same, even minus even will be even minus odd will be odd, odd minus odd will be even. So for subtraction and for addition it is the same. So now here there are 5 numbers p, q, r, s, t. So let's assume that p, q and r are even, and let us assume that s and t are odd. So let's take the first statement here. So p plus q, even plus even will be even. So this is even. Now even plus r is even plus even again. So this much will be even. Then even minus odd is odd. So odd minus odd will give you even. So this is correct. Understood? So now let us take the second statement. Here if you put like this, if I consider p, q, r are even and s and t are odd. So here I am writing the second statement here. 2p plus q plus 2r minus 2s plus t. Okay, so 2p, p is even, so 2p will be even, q is even, and r is even, so 2r will be again even. So this is even. So even plus even, again plus even. So this will be even. Okay, now s is odd. S is odd here. So 2 into s, 2 into any number will be even. So this become even. So even minus even, again this is even. Okay, now this is t is odd. So even plus odd is odd. So you will get this as odd. So you might think that this statement is correct, but here UPSC have said that not necessarily in order. So that is actually very important. So if I consider in the same statement, if I consider p, r and s as even and q and t as odd, let's see what happens. Okay, so this is 2p will be even plus odd is odd, this is odd. Now 2r is even, r is even, so 2r will be even, odd plus even will become odd. So this is totally odd. Okay, now s is again even, so odd minus even will be odd. So this is totally odd. Now t is odd, so odd plus odd will become even. So if I take in this order, I will get this as even. So this statement, second statement, can be odd or even. So we cannot say that this is definitely odd. So statement 2 is actually wrong and statement 1 is only correct. So 1 only is the answer here. So let's look into the next question. Consider the following in respect to prime number p and composite number c. So again, I am again telling you that you have to be thorough with the concepts of what is prime number, what is composite number, what is natural number, the concepts of odd number, even number. So these type of things are actually the UPSC is repeating these things, okay, in many questions. So that is actually very important. So now in this type of question, what you need to do, just assume some prime number and composite number and just put it to these statements and check whether the given statements are correct or not. And here one thing is that it is saying can be. So even if it satisfies in one condition, this statement is going to be correct, because can be is a possibility. So possibility means even if it is correct in one of the condition, you can take it as a possibility. And if the statement is like 2p plus c is definitely odd, then it has to be satisfied in all the conditions. Okay, so now let us assume some values for p and c. So it is said that p is a prime number and c is a composite number. So if for example, let's assume p is equal to 2 and C is equal to, let's say, 9. Okay, so P 2 is a prime number and 9 is a composite number. So if I take the option 2, 2P plus C, 2P is 4, 4 plus 9 is 13. It can be odd. So 2 is correct. Now, second statement, let's take the third statement now. I am assuming P as 3. Okay, P as 3 means 3 is a prime number and C is 9. Now, P into C is 3 into 9 is 27. It's an odd number. So PC can be odd. So that is also correct. Now we have the first option. So I am taking P is equal to 11. 11 is a prime number and C is equal to 9. So P plus C is equal to 20 and P minus C is equal to 11 minus 9 is equal to 2. So 20 divided by 2 is equal to 10. 10 is an even number. So 1 is also correct. So all the statements are correct. So option D is the right answer. Okay. So let's see the next question. A 3-digit number ABC on multiplication with D gives 37DD, where A, B, C and D are different non-zero digits. So they are different. That means they are distinct and they are non-zero. So 0 won't come. Now what is the value of A plus B plus C? So it's given that A, B, C into D will give you 37DD. So this type of concept from number system has been repeatedly asked. I think there are 2 questions in this year itself. So you have to be very careful, you have to study this kind of questions very well. Okay, and even before this, that is in 2021 and 2022 also, this type of questions has been repeated. So this is actually very important topic. So you have to study this very well. So in this type of questions, you have to find out the values of A, B, C and D which satisfies this condition. So there are some tricks, not tricks, I would say, some approaches that you can use here. So just see how I am solving this one. Okay, so here first thing that you need to understand is that here the answer is a number which is greater than 3000. 37DD will be a number greater than 3000, right? Now the maximum value of ABC is a 3-digit number. Okay, so let's forget that it is distinct. Okay, so the maximum 3-digit, the largest 3-digit number is 999. Okay, so 999 into 1 will give you 999. Okay, so D will not come 1. D won't be 1 because even if D is 1, you won't get a number greater than 3000 if D is 1. The maximum is that you are going to get if D is 1 is 999, right? So D won't come 1. Similarly, if D is equal to 2, the maximum you are going to get is 999 into 2, which is a number which is approximately equal to 2000, which is just less than 2000. So D equal to 2 also won't come. Now, if D is equal to 3, 999 into 3 is actually a number which is approximately equal to 3000, just less than 3000. So D equal to 3 will also not come. So the values could be D is equal to 4, 5, 6, 7, 8 or 9. So we eliminated the possibilities of D, 1, 2 and 3 won't come. So this is the first thing that you need to understand if you get a question like this. If you get a question like this, you have to first find out those numbers which won't come. So here I identified that 1, 2 and 3 are not coming for D. Okay, so now you can actually substitute different values of D and then find out the number. Okay, so here another trick that you can use here is that for example, here C into D is coming D. So let's assume that C is equal to 1. Okay, let's say that C is equal to 1. So 1 into D will come D, and again B into D is also D, right? B into D, so C into D is D. I wrote this D here. Now B into D also coming unit digit D. So how many possibilities will be there? What are the different possibilities? For example, if D is equal to 4, B can be 6, right? Because 6 into 4 is 24. The unit digit is 4. So 6, 4 is possible. 5 is also possible. For a value of D equal to 5 is also possible, right? Because 3 into 5 is 15 or 9 into 5 is 45, right? So D is equal to 5 is also possible. D is equal to 4 is possible. D is equal to 5 is possible, right? Now D is equal to 6 possible. If D is equal to 6, then 6 into 6 is 36. But in that case, B and D will become equal. 6 and 6 is becoming equal, right? So 6 won't come. There is no other possibility in which the if a number is multiplied by 6, then you will get 6. There is no other possibility. Only 6 into 6 is going to give you 36. So D equal to 6 won't come. Similarly, D equal to 7 also won't come, because any number multiplied by 7, the unit digit is not going to be 7. Just look into the multiplication table of 7. 7, 14, 21, 28, 35. Are you getting the unit digit as 7? No. So 7 won't come. Now, what about 8? 6 into 8 is 48. So last digit is coming as 8. So D equal to 8 is also possible. What about 9? 9, just look into the multiplication of table of 9. 9, I'm not taking 1, because even if I take 1 here, then one more number have to be. So 1, if you multiply 1 with any number, you're going to get that number. So 1 I am not considering, because here 2 numbers when multiplied by D is going to give you D, right? So there is no other number for 9 also. So 9 also won't come. So these are the different possibilities for D. Now just put D as 4. So if I am putting D as 4, you will get ABC into 4 is equal to 3744. Now just divide 3744 by 4. Just look into what is the value of ABC. Okay, so 3744 by 4, 9 4s are 36, then 14, 3 4s are 12, and 24, 936. So you got ABC as 936. Okay. So this is actually satisfying, because 936 into 4 is equal to 3744. It's satisfying because all these numbers are distinct and non-zero. Okay, so actually once you get this, you can actually add these things. 9 plus 3 plus 6. 9 plus 3 plus 6 is 12 plus 6, 18. So 18 is the right answer. But I will just show you what will happen if I put D is equal to 5. So D is equal to 5 means you will get 3755. Now if I divide this by 5, because in that case you will get ABC into 5. When I am substituting D is equal to 5, you will get ABC into 5 is equal to 3755. So just find out what is ABC. So 7 into 5 is 35, right? Now 25, 5 into 5 is 25, but see here 5 is repeating, then it will become not distinct. So this 5 won't come. Similarly, if you substitute 8 also, it's the numbers going to be the same. 8 will come 2 times. So it won't be distinct. So 8 will also won't come. So D equal to 4 is the right answer. So this is the right answer. 18 is the right answer. Okay. So now let's move on to the next question. For any choices of values of x, y, and z, the 6-digit number of the form xyz is divisible by. So we need to see xyz is divisible by which of the numbers given, that is 7, 11, or 13. So here, if for some students, if they see the xyz, it's actually difficult for them to solve. So you can assume some values for x, y, and z. That will be better here. So I'm just assuming x equal to 1, y equal to 2, and z equal to 3. You will get 1, 2, 3, 1, 2, 3, right? xyz will become 1, 2, 3, 1, 2, 3. So now we need to check whether 1, 2, 3, 1, 2, 3 is divisible by 7, 11, and 13. We need to check that. So here for 7, you can apply the divisibility rule of 7, which is 1 minus 2 minus 3 minus 1, 2, 3. So this is the divisibility rule of 7. If you don't know it, you can watch the lecture videos on divisibility rules. And also I have given some additional lecture on divisibility rule. So you can watch that. So 1 minus 2 minus 3 minus 1, 2, 3. Just write these numbers here. 1, 2, 3, 1, 2, 3. So if you see here, so this will come multiply. So this and this will get cancelled, right? Because this is 1, this is minus 1. This is minus 4, this is plus 4, cancelled. Minus 9 plus 9, cancelled. So it will answer will be 0. So since 0 is coming, it is divisible by 7. If you apply this divisibility rule for 7, if you are getting 0 or a multiple of 7, then it's going to be a multiple of 7. So 1, 2, 3 is divisible by 7. Now just for 11, we have to apply the divisibility rule for 11. For 11, what we need to do? We need to add the alternate numbers. So here 1 plus 3 plus 2. 1 plus 3 plus 2 minus 2 plus 1 plus 3. 2 plus 1 plus 3. So 1 plus 3 plus 2 is 6. 2 plus 1 plus 3 is also 6. 6 minus 6 is 0. So if you get 0 or a multiple of 11, then it's going to be a multiple of 11. So 11, 1, 2, 3, 1, 2, 3 is also a multiple of 11. Now just check for 13. The divisibility rule for 13 is 1, 4, 3, minus 1, minus 4, minus 3. Just put 1, 2, 3, 1, 2, 3 here. Then multiply. Here also you can see this is 1, this is minus 1 cancelled, 8 and minus 8 cancelled, 9 and minus 9 cancelled. You will get 0. So if it's 0 or a multiple of 13, it's going to be a multiple of 13. So 1, 2, 3, 1, 2, 3 is a multiple of 13 also. So this number, any number xyz will be a multiple of 7, 11 and 13. So D is the right answer. Okay. So let's look into the next question. 125 identical cubes are arranged in the form of a cubical block. How many cubes are surrounded by other cubes from each side? Actually, this is similar to the painted question. So if you are given a painted question like a cube, it is painted on all sides and it's divided into 125 cubes. Okay. Then if you are asked like how many cubes are there where none of the side is painted, it's actually similar question. Okay, but UPSC wanted to make you think more. That's why they have given like this. So if you take this is a cube which is divided into 125. If 125 is the number of cubes, then n, that is the division of each side, will be equal to cube root of 125, which is equal to 5. So each side will be divided into 5. So that's how I have drawn this cube. Okay, so here the question is how many cubes are surrounded by other cubes from each side. So you need to remove these cubes. These are outside cubes. So just remove these cubes. So I have to remove all these cubes and all these cubes, right? All these cubes and all these cubes I am removing. Then I have to remove the top ones as well. Here also, here also. So how many will be remaining? 1, 2, 3, 4, 5, 6, 7, 8, 9 inside. Inside means there will be like this. So 9 into 3 will come. 9 into 3 is 27. So this is the answer. Or similarly, the same question, you can apply the formula of none of the side painted also. None of the side painted formula is n minus 2 whole cube, right? So that is n is here 5. So 5 minus 2 whole cube is 3 cube, which is equal to 27, right? So in that way also, you can find out the answer. Okay. So now let us look into the next question. So this is a question from permutations, but if you don't need to know all the concepts of permutation here. If you read the question very well, you can solve this question, but this is actually a tricky question. So let's see how we can do this. So how many distinct 8-digit numbers can be formed by rearranging the digits of number 1, 1, 2, 2, 3, 3, 4, 4 such that odd digits occupy odd position and even digits occupy even position. So there are 8 positions here, 8-digit number, right? 1, 2, 3, 4, 5, 6, 7 and 8. So these are the 8 different positions. Now the odd digits here are 1 and 3 and even digits are 2 and 4. So here in the first position 1 and 3 will come because odd digits will come in the odd position. Here also 1 or 3 will come. Here also 1 or 3 will come. Here also 1 or 3 will come. And here 2 and 4 will come. Here 2 or 4 will come. Here 2 or 4 will come. And here also 2 or 4 will come. This is how we need to do it, right? So now I am first taking 1 and 3. So let's see how we can arrange 1 and 3. So if I put 1 here and 1 here, I can put 3 here and 3 here. This is one possibility, right? Now if I put 1 here, if I put 3 here and 1 here, this is also a different possibility. Similarly, if I put 1 here, 3 here, 1 here, 3 here, this is a different possibility. Now if I put 3 here and 3 here, 1 here, 1 here, it's a different possibility. If I put 3 here, 1 here, 1 here and 3 here, this is again another possibility. Now 3, 1, 3, 1 is also a different possibility. So in this way, 6 ways we can arrange 1 and 3. So in 6 ways we can arrange 1 and 3. Similarly, how many ways you can arrange 2 and 4? It will also be 6, right? So in this case, how many numbers will be possible? Like I can put 2 here, 2 here, 4 here, 4 here. This is one possibility, right? Now I can put 2 here, 4 here, 4 here and 2 here. This is another possibility, right? So in this way, I can, similar to what I have done before, there will be 6 possibilities for this number. That is, if I arrange 1 and 3 like this, then there is 6 possibilities of arranging 2 and 4. Again, if I arrange 1 and 3 like this, there will be 6 possibilities for arranging 2 and 4. Similarly, here also there will come 6, 6, 6 and 6. So totally 6 into 6, 36 possibilities will be there. So the answer is option C, 36. Okay. So let's see the next question. ABC working independently can do a piece of work in 8, 16 and 12 days respectively. A alone works on Monday, B alone works on Tuesday, then C works on Wednesday and so on. Okay. Now consider the following statements. The work will be finished on a Thursday and the work will be finished in 10 days. Let's see how we can do this. So in this type of question, work and time questions, it's actually very easy if you use the LCM method. So here we need to first find out the LCM of 8, 16 and 12, right? So 2, 4, 8, 6, again 2, 2, 4, 3, again 2, 1, 2, 3. So the LCM is 2 into 2, 4 into 2, 8 into 2, 16 into 3, 48. So LCM is equal to 48. So I'll assume total work is equal to 48. Total work is 48. We need to finish 48 work in order to finish the job. Okay. So A can do the work in 8 days, right? A can do a piece of work in 8 days. That means in one day, A will do 48 by 8, that is 6 work, right? Total work is 48. That means in 8 days, A is completing 48 work. So in one day, A will complete 48 by 8, 6 work. So this is one day. Similarly, B will complete 48 by 16, that is 3 work in one day. C will complete 48 by 12, that is 4 work in one day. Now, just without doing all other thinking and everything, just write these dates. That is, the work is starting on a Monday, right? So Monday, Tuesday, just write like this. You don't need to do all other calculations and all. Thursday, Friday, Saturday. So the work is going like this, right? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So it's going like this. So now let's see. So in the first day, A is working. That means 6 work will complete because A in one day will do 6 work. Now in the second day, that is in Tuesday, B is going to work. So B will complete 3 work. Okay. So in the next day, that is in Wednesday, C is going to work. So C will complete 4 work. So in the first 3 days, how many work is completing? 6 plus 3, 9 plus 4, 13 work is completing in the first 3 days. And next 3 days also 13 work will complete because net A, B, C and they are repeating the work, right? Again in the next day, 3 days, again 13 work will complete. So total 13 plus 13 plus 13, 39 work will complete in the 9 days. It will complete in 9 days. Now after this, again A is going to work. So A will do 6 work, right? So in the 10th day, 45 work is completed. Total work is actually 48. So in the 10th day, 45 is completed. In the 11th day, B is going to work. So B will complete 3 work. So 45 plus 3 is 48. So in the 11th day, 48 work is completed. So the work will take 11 days to finish. Here it says that will be finished in 10 days. So this is wrong. Now it is completing on a Thursday. Correct? It is completing on a Thursday. So the first statement is correct. So 1 only is the right answer. So now let us look into the next question. Actually, this question is very similar to the first question that we have done in this video. Okay. So Raj has 10 pairs of red, 9 pairs of white and 8 pairs of black shoes in a box. If he randomly picks shoes one by one without replacement from a box to get a pair of red shoes to wear, there is a red there, okay? Red shoes to wear. What is the maximum number of attempts he has to make? So he has 10 pairs of red. So here you need to understand pair means 2 shoes, right? 1 pair means 2. So there are total 20 red shoes are there. White, total 9 pairs are there. That means 18 white are there. And 8 pairs of black is there. That means total 16 black shoes are there. Now if he randomly he's just picking one by one. Now you need to get a red shoes to wear. So what is the maximum number of attempts he has to make? Maximum. Okay. So let us assume that just like the first question, let us assume that he first one by one he's picking the shoes. Let us assume that he picked all white first. So in the first 18 tries, he's going to pick all the 18 shoes. Now in the next 16 tries, let's assume that he's picking black shoes. So in the next 16 tries, he will pick only black shoes. Okay. Now next one, the next shoe he will pick will be, surely it will be a red shoe, right? Because white and black is completed, so there is only red remaining. And in the next one also he will pick again a red shoe. So he got a pair of red shoes. Now the total possibility is 18 plus 16, 34 plus 2, 36. So if we pick 36 shoes, we can surely say that there will be one pair of red shoes will be there in the 36 shoes, right? So option B is the right answer. Okay. So now let us see another question. In how many ways a batsman can score 25 runs by scoring single runs, fours and sixes only, irrespective of the sequence of scoring shot? And one thing I am going to tell you that UPSC has a tendency to ask questions from cricket based questions. UPSC has asked in the past as well in CSAT. So if you are a student who doesn't like cricket, or if you are a student who doesn't watch cricket, at least try to know the how the runs are scored, how the basic things go. Try to learn it, okay? Because sometimes the questions asked will be a very simple question. Actually this is a tricky question, but it will be good if you know some basic things about cricket. Okay, so let's see how we can do this one. I think I have done in the permutations and combinations itself, I think I have done a denomination based question, like 100 rupee note, 50 rupee note. And if I have 100 rupee note, I have 50 rupee note, and I have, let's say, 10 rupee note. Then in how many ways you can pay a bill of so and so money? So this is a similar question actually. The only thing is that it is 1 run, 4 run and 6 run and total 25 runs. So it's similar. So let's see how we can solve this one very easily. Okay. So in this type of question, what you need to do is that just divide this into, we have 1 run, we can score 1 run, we can score 4 run, or we can score 6 runs, and total runs we need to score is 25. Okay, so here the largest number is 6, largest the runs that we can score largest in one ball is 6, right? So just assume what happens if we score 0 sixes, what happens if we score 1 6, 2 6, 3 6 and 4 6. That is the maximum, right? Because 4 into 6 is 24. So if I score 4 sixes, it will become 24. So total is 25. So that is the maximum sixes that you can score in a score of 25, right? 4 sixes. So we will take all these possibilities. What happens if I score 0 runs? How many possibilities are there? Oh, sorry, how many 0 sixes? How many possibilities are there? Then if I score 1 6, how many possibilities are there? So we will do like that. Okay. So let's say I've scored 0 sixes. Then I can score 0 fours. Then in that case, all the 25 runs I need to take single. Now if I score 1 4, right? If I score 1 4 in 25, 1 4 is there. That means the rest is 21, right? So all that 21 run I need to run singles. Now if I score 2 fours, 8 runs are gone. So balance is 25 minus 8 is 17. So 17 runs I need to score singles. So in this way, how many possibilities there will be there? If I score 0 4, 1 4, 2 4, 3 4, 4 4, 5 4 and 6 4. That is the maximum, right? 6 4, 6 into 4 is 24, right? So in 25 maximum I can score 6 fours if there is no sixes, right? So these are the different possibilities. So total possibilities of when I hit 0 sixes is, how many possibilities are there? 1 2 3 4 5 6 and 7. So total 7 possibilities will be there. You don't need to consider this one, because if the number of 6 and 4 is fixed, the number of singles will also be fixed, right? So just consider 6 and 4, the largest numbers. Always do that. If you are asked a denomination based questions, also do in a similar way. If you are having 50 rupee note and 100 rupee note, take, and 10 rupee note, take 100 rupee note as a constant first. That means what happens if I use 0 100 rupee note, what happens if I use 100 rupee note, like that. Then check what happens to the 50 rupee note. 10 you don't need to consider, because 10 will get fixed if 100 and 50 are fixed. So that's what we are doing here. Now let's say if I am hitting 1 6, 1 6 means already 6 runs is gone, balance is 19 runs. So in that 19 runs I can either score 0 4, I can score 1 4, 2 4, 3 4 and 4 4. That is the maximum. 4 into 4 is 16, right? So here how many possibilities are there? 1 2 3 4 5. 5 possibilities are there. Similarly, if I score 2 sixes, 12 runs are gone, balance is 13 runs. In that 13 runs, I can hit a maximum of 3 fours because 3 into 4 is 12. So either 0 4, 1 4, 2 4 and 3 4. Total 1, 2, 3, 4, 4 possibilities are there. Similarly, if I hit 3 sixes, 18 runs are gone, balance is 7 runs, I can only hit 1 4. So either 0 or 1 4. So 2 possibilities are there. Now if I hit 4 sixes, that is 24 runs are gone, balance is only 1 run. In 1 run, I can only score by single. I cannot hit any 4. So 0 fours are there and 1 single will be there. This is one possibility. So total number of possibilities is 7 plus 5, 12, 12 plus 4, 16, 16 plus 2, 18, plus 1, 19. So total 19 possibilities will be there. Option B is the right answer. So now let us look into the next question. There are 4 letters and 4 envelopes and exactly 1 letter is to be put in exactly 1 envelope with correct address. If the letters are randomly inserted into the envelopes, then consider the following statement. So here it says that we have 4 letters. Let's say these letters are A, B, C and D. So A, B, C, D are 4 letters. Now you have 4 envelopes. Let's assume that 1, 2, 3 and 4 are our envelopes. And let's say that A has to go in envelope number 1. B has to go in envelope number 2. C has to go in envelope number 3 and D has to go in envelope number 4. Let's say this is the correct sequence. Now let's read the first statement. First statement says that it is possible that exactly 1 letter goes into an incorrect envelope. Now let's say that A goes into the incorrect envelope. Let's say we put A into the envelope number 2. So that's incorrect. So let's say C and D goes into the correct envelopes. So C is in 3 and D is in 4 envelope number 4. Okay. So since I have put A in the incorrect envelope, B also has to go into the incorrect envelope, right? There is no other option. That means we cannot actually make exactly 1 incorrect. If one of the letter is incorrect, 1 more letter will become incorrect, right? So this is wrong because we cannot, it is not possible that exactly one letter goes into a wrong envelope. If 1 goes into wrong envelope, 1 more will go into the wrong envelope. Now let's take the second statement here. Second statement says that there are only 6 ways in which only 2 letters can go into the correct envelope. So 2 letters have to go into the correct envelope. Now let's say that A and B goes into the correct envelope and C and D are wrong. That is one possibility. Now let's say that A and C goes into the correct envelope. Then other B and D goes into the wrong envelope. So that is another possibility. Now A and D goes into the correct envelope and others go into the wrong envelope. That is another possibility. Now B and C is a possibility because B and A we have already taken here. So B and C is a possibility. B and D going correct is a possibility. Similarly, C and D going correct is a possibility. So these are the different possibilities of exactly 2 letters going into the correct envelope, right? So total 1, 2, 3, 4, 5, 6 possibilities are there. So this is actually correct. So option B, 2 only is the correct answer here. Okay. So now let us look into the next question. So one thing that you need to understand is that I think I have already mentioned this in the reminder theorem lecture. If you get a question like this, most probably the answer is going to be 0. Most probably. I'm not saying always it is 0, but most probably the answer is going to be 0. Because in this type of question, what happens is that this number, the number that you got will be exactly divisible by 100. So let's see how we can do this one. So here 85 into 87 into 89 into 91 into 95 into 96 by 100. So just try to simplify this one by cancelling out the same number in both numerator and denominator. So here I can cancel this by 5. So if I cancel this by 5, it will become 90. Here if I cancel by 5, it will become 20. Again here there is a 5 and here there is a 5. I can cancel by 5. So it will become 17 here if I cancel by 5. Here it will become 4. Now 96, if I cancel by 2, it is going to become 48. If I cancel by 2, it is becoming 2. Again 48 is divisible by 2. I can cancel 2 in both numerator and denominator. It will become 24 and it will become 1. So that means our denominator is becoming 1. That means all the things are getting cancelled. That means this number, the number that is formed, is exactly divisible by 100. So the remainder will be 0. Okay, so the answer is 0. So let's look into the next question. This is also actually an easy question. Here, if you know the cyclicity of power, which I have already mentioned in the lecture on surds and indices, you can solve this question. Okay, here first we need to solve what is this one, 9 into 7 into 5 into 3. If you do that, 9 into 7 into 5 into 3 is 945. So we need to find out what is the unit digit of the expression 57242 raised to 945. Okay, so we first just need to look into the last digit here or unit digit here. That is, we just need to check what is the unit digit of 2 raised to 945. Okay, so we know that 2 raised to 1 is 2, 2 square is 4, 2 cube is 8, 2 raised to 4 is 16. Okay, 2 raised to 5 is 32, 2 raised to 6 is 64, 2 raised to 7 is 128, 2 raised to 8 is 256. Now, if you see here, unit digits are repeating. That is called the cyclicity of power. So here 2, 4, 8, 6, 2, 4, 8, 6, it's going like that. So here if you see 2 raised to 4, 2 raised to 8, unit digit is 6. That means 2 raised to a multiple of 4, you will get 6 in the unit digit, right? So here it is 945, right? So you know that 944 is divisible by 4. Because for to check the divisibility rule of 4, you just need to check the last 2 digits. 44 is divisible by 4. So if you do 2 raised to 944, the unit digit will be 6. So 2 raised to 945, using the cyclicity, after 6, 2 is coming, right? After 6, 2 is coming. So 2 will be the answer. You can also do this in a different way. So this is 945. Cyclicity of 2 is 4 because after 4, it's repeating. Right? 2, 4, 8, 6, 2, 4, 8, 6. So 4 after 4 cycles it's repeating. So just divide 945 by 4. Okay, you will get remainder as 1 because I'll do it. 2 4s are 8, 14, 3 4s are 12, 25, 6 4s are 24. So you will get remainder 1. So just check what happens. Just take the remainder, that is 2 raised to 1. Just check remainder is 1. So just put 2 raised to 1. So just check what happens for 2 raised to 1. What is the unit digit for 2 raised to 1? 2 raised to 1 is 2. So answer is 2. In that way also you can solve this. Okay. So let's take the next question. If A, B, C and D, F are both 3-digit numbers such that A, B, C, D, E and F are distinct non-zero digits. Okay. It's distinct and non-zero. Now, if you look into the paper, in many places you can see distinct, non-zero and all. So that is actually very important. So you cannot take 0 here and you have to take all the numbers different. That is very important. Okay. Such that ABC plus DEF, ABC plus DEF is equal to 1, 1, 1, 1. What is the value of A plus B plus C plus D plus E plus F? So here there are actually many possibilities are there. So for different values of A, B, C and D, F, you will get same 1, 1, 1, 1 answer. So just try to come into one of that possibility. So just take any numbers here. So if I take C is equal to 8, any number, 8 plus 3 is 11. So 1 will come here and remaining 1 will come there. Now if I am taking this as 4 plus 1 is 5. So I need to take this as 6 because 5 plus 6 is 11. 1 will come here and 1 will come here. Now if I take this as 9 plus 1 is 10. If I put 1 here, then it is becoming 11. So if I take 948 plus 163, it's going to be 1, 1, 1, 1. So this is one possibility. Now if you add 9 plus 4, that is 13, 13 plus 8, 21, 21 plus 1, 22, 28 and 31. You are going to get 31. So 31 is the answer. So 948 plus 163 is not the one possibility here. There are different possibilities. For example, if I put 9, okay, if I put C as 9 and if I put F as 2, 9 plus 2 is 1, then 1 will come, 9 plus 2 is 11. So 1 will come here and 1 will come here. Now if I put 3 here, 3 plus 4 is 3 plus 1 is 4, then plus 7 is 11, 1 will come here and 1 will come here, right? Now if I put 6 here, 6 plus 1 is 7, then plus 4 is 11. Okay, it also comes 1, 1, 1, 1. In this way there are several possibilities. So even if you put any possibility, you are going to get the total a plus b plus c plus d plus e plus f is equal to 31. Okay. So let's do one more question. So this is actually a very tricky question. So d is a 3-digit number such that the ratio of the number to the sum of the digits is the least. What is the difference between the digit at the 100th place and at the unit place of d? So for example, let's take the smallest 3-digit number first, that is 100, right? So 100 divided by the sum of its digits, that is 1, we will get 100. So this ratio has to be very minimal. Now if I take 101, then the sum of digits is going to be 1 plus 0 plus 1 is 2. So 101 by 2, it's becoming 50.5. So approximately it's 50. So it's becoming reducing. So we have to take those number in which it is the least. Okay. Now if I take in this way, if I take 109 by 10, because sum of digit is 10. So 1 plus 0 plus 9 is 10. It's going to get 10.9. So this is smaller now. It is smaller than 150.5. This is 10.9. So in this way, you need to try different possibilities. Now if I put 110 divided by 2 is actually 55. It's increasing. So that's anyway, it's not going to happen. Now if I put 119 divided by 11, you are going to get, it's approximately, if you do it, you will get 10.8 something. Okay, 10.8. So it's actually less than this one. So now this is not the answer. So this, we got a value which is less than 10.9. So just try some more values now. So let's say if we try 129 by 9 plus 2, 11 plus 12, you are going to get a lesser value than 10.8. In this way, if I increase and increase, finally you will get 199 by 9 plus 9 is 18 plus 1, 19. So this is equal to 10.4 something. Okay. So actually, if you try this kind of different possibilities, you will understand that 199 by 19, that is the least value. Okay, that is the least value for the ratio. So our D, the number is 199. So the answer is 9 minus 1. The difference between the digit at the 100th place and at the unit place, 9 minus 1 is equal to 8. This is actually very difficult question. It's actually very difficult to understand which is the least, because you have to try so many possibilities. But if you have the time, actually you can solve it by taking the different numbers as I have taken here. Okay, so this is our first part of the video. So I have done 26 quantitative and reasoning part. So next other questions will be coming as part 2. Okay, so thank you so much. If you like this video, please do subscribe, share and support. And if you have any doubts regarding the different questions that I have discussed, or if you have a different method, okay, even if that is also, you can post it as comments in the comment section as well. Okay, and also if you want to join my Telegram channel, you can join it using the link that I'll be providing in the description box. So thank you so much.